I'm going to solve a similar problems. I think this looks like very much your problem, even though I couldn't read exactly what the polynomial was, but I think this should do it. Okay, so first, we're going to factorize this because I see there is a common factor in this polynomial, which is x squared, right? You know, if you look at each term, then there is an x squared as a common factor. So I can go ahead and pull out the x squared from each one. And this will leave me with 6x squared. And this will be 5x. And this is negative 9. So this is quadratic now. So I can try to factorize this separately over here. So I can factorize this. Okay, so I'm going to use this thing called a times c, and then b right here. So a is 6, c is this one. So if you multiply these two numbers, negative 54, and the middle one is negative 5. So I'm going to find two factors of this number such that the sum is negative 5. So we're going to start generating the factors of this such that the sum is negative 5. So what could be, what are the factors? What are the possible factors? Well, this could be, see, 9 times 6, but 9 and 6, when you add it, is 15, and when you subtract it, it's going to be 3. So that's not quite going to work. Well, we can try to generate more. So this is like 3 times 3, and this is like 3 times 2. So we could do, let's see, 16. Okay, so let's also check if this is factorable or not, right? Because we can also look at b squared minus 4ac, and if this is not a perfect square, then this is not factorable. So we can check that too. So b is negative 5 squared, 4 times 6 times negative 9. This is 25. And then over here now I have 6 times 4 times 9, and that will be, let's see, 36, 18, 216, right? And then we'll have positive 216 plus 241. So I mean the 225 plus 216, and this is going to be 241, and that's not a perfect square. So that means this is not factorable. So I tried here, but you see it didn't work. I couldn't find a factor. So, and the reason was that this is not a perfect square, so it didn't work there. So then we can just go ahead and use the quadratic formula to compute the zeros of this guy, right? To find the zeros of this function, which I already compute this. So all I need to do is do negative b plus minus, this is b squared minus 4ac divided by 2 times a. And like I said, I already compute what's inside the radical, which is going to be 5 plus minus square root of 241 divided by 2 times 6. And that will be, so now I will have two solutions there. One of them is going to be 5 plus square root of 241 divided by 12. And the other one is 5 minus square root of 241 divided by 12. So these two are distinct factors. So they're going to have multiplicity 1, basically. And then now this right here is another factor, but that one, it repeats twice because x squared means x times x. And if you set one of this to 0, then it's 0, but this will have multiplicity 0, basically. Well, now my zeros are x equal to 0. My zeros are x equal to 0, and this other radical ones, right? This one and that one. Then I need to pick and each one. So this one has multiplicity 2. This one has multiplicity 2 because it repeats twice, and each of this has multiplicity 1. So this is with the multiplicity 1. This is with multiplicity 1. Now then you just put your answers accordingly, starting from the smallest one to the largest one. So this is probably going to be the smallest one because this is going to be a negative number, and then this is going to be the largest one. This is largest. Okay, so you will, the largest one, this will go here, and then you will put 0. 0 has multiplicity 2. This has multiplicity 1. Sorry, the smallest one goes here. Sorry. Largest one will go here. This is the largest one. It has a multiplicity 1. 0 has multiplicity 2. And the smallest one is negative, right? So the smallest one is like 5 minus this divided by 12, and the multiplicity of that is also 1. And this is 5 plus this divided by 12. So this should do it. This is very similar to your question, so I hope it will help you.